Now we are starting question number 3 of this paper. May June 9709 is the code /51 with the year 2023 for this statistics paper. The question statement is: find the number of the different arrangements of 8-letter words coconut. So there is a word specifically mentioned their arrangement. So it means it is the permutation topic. So we can have this topic like of the permutation. So basically there is 2C, 3 O's, 1 N, 1 E, and 1 D. So our total arrangement of this word is 8 factorial because there are 8 words in this, but 2 C's and 3 O's are repeated. So it will be divided by 2 factorial into 3 factorial, and that answer is basically equivalent to 3360. Now, part B of this. Find the number of the different arrangements of this word, 8-letter words in the word coconut, in which the first letter is O and the last letter is N. So they have mentioned conditions there that the first letter is O and the last is N there. So we can have this arrangement as the first letter as O and the last letter is N there. So basically these two letters are been fixed in this part, and the word is this coconut. So it means these two letters, there is no option for this part there. So left letters there are 6. So it should be equal to 6 factorial or 6p6. That is the same answer. Divided by, because one O is not there. So it should be left there 2 O's. And N is already there. So it means 2 C's are repeating there and 2 O's are repeated there. So it should be equal to 6 factorial divided by 2 factorial into 2 factorial. And that answer is basically equal to 180. Now the part C of this topic. Find the probability that a randomly chosen arrangement of these 8-letter words in the word coconut has all 3 O's together, given that 2 C's are next to each other. So it is given that 2 C's are next to each other and all O's are together. So we can have this option there. Probability of all O's they are together, given that 2 C's they are together. And you are going to find out the probability of that option there. Let's say these 3 O's are going to be represented by A, and these two C's are going to be represented by B. And we know that probability of A intersection B is probability of A intersection B over probability of B there. But in this question, three O's are all together. So we can make that option in this way, that all O's are together, that is represented by A there. So option A is all O's are together. And then there are two N's, they are together, C's, they are together. And the rest of the waters left there, NAD there. So it is basically equal to, this is 1, 2, 3, 4, 5. So it should be equal to 5 factorial divided by probability of B. So B event is there when two C's are together. So we make this column as two C's, then O, then O, then O, then N, then E, and then D. So this option will be equal to 1, 2, 3, 4, 5, 6, 7. So we can write this thing as 5 factorial divided by 7 factorial, but there are two C's, they are together. So you can further divide it by 3 A's, so 3 O's, which are of the same type. So it should be equal to divided by 3 factorial there. So this thing is answer equal to 5 factorial into 3 factorial divided by 7 factorial. And this answer of probability of A given B is equal to 120 over 840. This and this cancel. 12 ones are 12 sevens are. So it should be equal to, the probability of that is equal to 1 over 7 of that statement there. When all O's are together and all C's are next to each other. So that means what, they are together also there. So we have made this option, and you can find out the solution of this problem with respect to this problem number 3 of this topic of stat there.